I'm Anil Kumar sharing with you a video which is for my student Anna. She wants to understand how to apply sum and difference formula to find the exact value of some trigonometric expressions. We'll take up 3 examples in this particular video. We'll evaluate using sum and difference the value for cos of 75 degrees, sine of 11 pi by 12, and tan minus 5 pi by 12. When I say sum and difference, it really means these set of formulas. Let me write them. Sine A plus B is equal to sine A cos B plus cos A sine B. If you have minus, then the only change is that this becomes minus. Similarly, we have for cos A plus B. Cos A plus B is cos A cos B minus sine A sine B, correct? In this case, if we have cos A minus B, then it is modified as such. Okay, to complete, let me also write down formula for tan A plus B, which is tan A plus tan B over 1 minus tan A tan B. And if this is minus, in that case we'll just change these signs. So I hope that is absolutely clear. So we are going to use these formulas to find exact value of the given trigonometric expressions. Let me begin with cos of 75 degrees. 75 can be written as combination of what two numbers where we can use the exact values. Well, it is 45 degrees plus 30 degrees, correct? That gives you 75. And when you apply this formula, cos A plus B, and expand, then what do you get? So we are going to apply this formula now for A plus B, cosine function. So you get cos of A is 45. So we say cos of A, which is 45 degrees, times cos of B, which is 30 degrees, minus sine 45 degrees, sine 30 degrees. So most of you know these values. We'll just make our special triangles to recall, right? So this is 45 degrees triangle, and let us say this is 30, 60, 90. So in 45 degrees triangle, we can write the sine as 1, 1, square root 2. I prefer to use the values square root 2, square root 2, and 2, so that we don't have to rationalize. Is it okay? This is for when these two sides are equal, so that means 45 degrees. And for 60, 90, 30, the side ratios is 1 to square root 3, correct? So we'll use these values and simplify. So cos of 45 degrees is square root 2 over 2 times cos of 30 degrees, you have to look from here, square root 3 over 2, minus sine 45 is same as cos 45, and sine 30 is half. So you can now simplify this. You get common denominator of 4. So you write this as square root 6 over 4 minus square root 2 over 4, which is equal to 4 is the common denominator, square root 6 minus square root 2. Right? Some of you may take square root 2 common, right, and then write this as square root 3 minus 1 over 4 as your exact value for cos 75 degrees. Is that clear? Right? So now let's move on and do sine 11 pi by 12. So let's evaluate sine 11 pi by 12. Now let's first try to understand the trigonometric ratio, especially the angle When I say 11 pi by 12, it really means that the terminal arm really is where? This position could be called as pi, which is 12 pi by 12. So 11 pi by 12 will be 1 less than that, right? So 11, and then so from here you go up to 11, right? So that is the position. So in this position you will notice 11 pi by 12. The related acute angle is pi by 12, correct? The related acute angle is pi by 12. And also, you are in quadrant 2. You know all are positive here. Sine is positive in quadrant 2, tan in 3, cos in 4. So we are expecting a positive answer. Related acute angle being pi by 12. So I could write my function as sine pi by 12. Is that clear? Is it okay? Some of you may use kind of, what should I say, 12 minus 1 and then figure it out. You could do that. Okay, what I'm trying to say here is you could write this as sine of 12 pi minus pi, that gives you 11 pi over 12. And then what you get here is sine of 12 pi divided by 12, let's do 12 pi divided by 12 minus pi by 12, right? Which is equal to sine of pi by 12 minus, pi minus pi by 12, right? 12 cancel. And you know sine pi minus pi by 12 is sine pi by 12. So that's an alternate. So let me call this as alternate. However, what is critical to understand is that you could write sine 11 pi by 12 as sine pi by 12. Is that clear? Now we need to write sine pi by 12 as a combination of two angles for which we know exact values. So what we have shown here is that sine 11 pi by 12 is indeed equal to sine pi by 12. Now, how do I write sine pi by 12 as combination of a and b so that I get two numbers here which are known for their exact values? That's the whole idea. Now, one way which some of you do is convert pi by 12 to degrees, right? So that is to say, you could do 180 divided by 12, and what you get is 15. So let me show you this work on the side. Not a recommended position, but okay. So what I'm saying here is pi by 12 is equal to 15 degrees, and 15 degrees could be written as 45 degrees minus 30 degrees. Does make sense to you? So then you get back to the radian part and write down, this is pi by 4 and this is pi by 6, and that makes sense. You get my idea, right? Pi by 4, pi by 6. Then you get it. But my recommendation is that you should try to split pi and work in pi. So we need 1. So we could do this as 4 pi minus 3 pi. Does it make sense to you? You don't have to really do it, but if you need, you may. Okay, I'm not saying never do, but in case you get stuck, that's an alternate method again. So let me again say this is alternate step. I'm not opposing to it, but I prefer to switch over to radians as we are working. So now we could write this as sine of, see, 4 pi by 12 minus 3 pi by 12. That gives you sine of 4 goes 3 times. So we get pi by 4 times 3 is pi by 3 minus 3 goes 4 times. So we get pi by 4. So we get 60 minus 45. So what we got here was 60 minus 45, which is also, we got 60 minus 45, which is also 15. So that will also work for you. Is that okay? So anyway, so I'll go with this. Okay. You could have got this answer by using 3 minus 2. Okay. So we discover new things as we solve. So now, basically, we need to find exact value for sine pi by 3 minus sine pi by 4. So let's do it. Let me keep this portion aside. Now we are going to expand sine pi by 3 minus pi by 4 using the compound angle formula. So that could be written as sine A cos B, which is sine of pi by 3 cos of pi by 4 minus cos A sine B cos of pi by 3 times sine of pi by 4. Now to get the exact values, it is good to use the special triangles. So one of the triangles which we are going to use is the one which involves pi by 3. So that is pi by 3. In that case, the sides are 1 to square root 3. The other triangle is the one with pi by 4, where two smaller sides are equal, 1 square root 2. Right? So better is to use the sides as square root 2, and this one as 2, right? So when you multiply, you get that ratio. So you don't have to rationalize for this particular triangle. So now we'll substitute these values. Sine pi by 3. So if you look from this side, opposite side is square root 3. We get square root 3 over 2. Cos pi by 4 will be square root 2 over 2 minus cos pi by 3 is half times sine pi by 4 is again square root 2 over 2. That gives you a common denominator of 4. Let's write down. And here you can take square root 2 common. And what you get is square root 3 minus 1. So that becomes the exact value for sine 11 pi by 3. Now as you noticed here, at this particular stage, sine pi by 12 was written as sine 4 pi minus 3 pi. Right? You could also write this as sine 3 pi minus 2 pi. Right? That also gives you pi by 12. So let's redo with different numbers. So we could also do sine pi by 12 as equals to sine of 3 pi minus 2 pi over 12. That gives you sine of 3 pi by 12, which is pi by 4, minus 2 pi by 12, which is pi by 6, right? And if you expand that, you get sine pi by 4 times cos pi by 6 minus cos pi by 4 sine pi by 6, correct? You could use this method also, the combination, and get the same result. So let's just complete this one. So what we get here is sine pi by 4 is square root 2 over 2 times cos pi by 6. Look from this side now. Cos is square root 3 over 2 minus cos pi by 4 is square root 2 over 2, and sine pi by 6 from this side half, right? So again you get the same result, common denominator of 4. You can take square root 2 common. You get square root 3 minus 1. So either formula you use, you get the same result. So I hope the steps are absolutely clear. We'll now take up the last example in this particular sequence. Now let us try to evaluate using sum and difference formula tan of minus 5 pi by 12. So first step is to figure out in which quadrant you are. When I say minus, that means we are moving clockwise, right? 5 pi by 12 means what? Well, if you go like this, then pi or 12 pi by 12 is this stage. So here we have 6 pi by 12, right? So 5 pi by 12 will be in quadrant 4. So let's say the terminal arm now is somewhere here, and that becomes 5 pi by 12. Right? So that gives you a related acute angle of 5 pi by 12 and quadrant 4. In quadrant 4, tan is negative, and therefore we can write tan minus 5 pi by 12 as equals to minus of tan 5 pi by 12. Is that clear? That is the first step, right? So first step is to figure out where you are. That decides the sign. We are in quadrant 4, and therefore the value of this expression is going to be negative. Then solve with related acute angles. So I hope you understand, right? So we have now a related acute angle, and in terms of this, which is 5 pi by 12, over the negative sign, we are going to find the exact value using sum and difference formula. So we could write 5 pi as what? Remember, we have to select numbers which could simplify when we divide by 12 in terms of pi by 3, pi by 4, pi by 6. Is it okay? So the combinations could be 4 and 1, but that really doesn't work so well. 3 and 2 is a better combination. So we can write this as 3 pi plus 2 pi. That is 5 pi, right? 5 pi by 12. And this gives you minus tan. 3 divided by 12 is 4. Plus 2 divided by 12 is 6. So immediately we get our special triangles, correct? Pi by 4 and pi by 6. So that is the key in solving these questions. So I hope with these three examples you have understood how we could easily do this, right? So if I'm working with pi by 4 triangle, normally, since we are working in tan, we can say 1 square root 2 as our sides. We don't use the hypotenuse in the formula. And for pi by 6, the sides will be 1 to square root 3. This is pi by 6, that's 90 degrees. This is pi by 3, correct? So now we can expand using the tan formula. So we can now write this as equal to negative, this is for that negative, tan A plus tan B, which is tan pi by 4 plus tan pi by 6 over 1 minus tan A, which is tan pi by 4 times tan pi by 6, correct? So that gives you negative tan pi by 4 is 1 plus tan pi by 6 is 1 over square root 3. 1 over square root 3 divided by 1 minus 1 times 1 over square root 3. This you could take common denominator of square root 3, that results into square root 3 plus 1 over square root 3 minus 1. Right? So that becomes the result. Now some of you may like to rationalize. It is kind of important. So we'll just extend this. We have square root 3 plus 1 divided by square root 3 minus 1. We are going to rationalize, that is to multiply by conjugate of denominator, which is square root 3 plus 1. So we get square of this in the numerator, which is 3 plus 2 times square root 3 plus 1, and in the denominator we get difference of square, which is 3 minus 1. So the result is we get negative 3 plus 1 is 4. 4 plus 2 square root 3 divided by 3 minus 1, which is 2. And now we can further simplify this and write this as equal to, let me write down here itself, minus 2 plus square root 3. Correct? So that becomes the final answer. So this is equals to negative, both negative, right? Since this is negative for both, correct? It's kind of like this. So, okay, so let me rewrite this as minus 2 negative square root 3. So that becomes the answer. So you could write this as minus 2 negative square root 3 as the exact value for tan minus 5 pi by 12. Let me summarize how we found the exact value for tan minus 5 pi by 12. Minus means clockwise direction. The terminal arm is in quadrant 4. Therefore, tan value is going to be negative. Acute angle is 5 pi by 12. So we get minus tan 5 pi by 12 as an equivalent expression for tan minus 5 pi by 12. Now you could write 5 pi as a combination of 3 pi plus 2 pi, which results into tan pi by 4 plus pi by 6. Use the compound angle formula to expand and then use special triangles to substitute the values, rearrange. At times, when you get square root in the denominator, it is important to rationalize. So I will recommend to rationalize and then write down your result as shown here. I hope the steps are clear. The 3 examples which we took in this particular video provides you with the variety, and I hope that helps you to understand the topic in total. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for watching and all the best.